What is Autograd and PyTorch for machine learning? Have you ever wondered how machine learning models learn from data? One of the key components that makes this possible in PyTorch is Autograd. So, what exactly is Autograd? Autograd is an automatic differentiation system in PyTorch that helps compute gradients or partial derivatives of tensors during the training of machine learning models. This is essential for updating the model parameters to minimize errors. When you work with tensors in PyTorch, you can set an attribute called requiresGrad to true. This tells Autograd to track every operation performed on those tensors. As you perform calculations, Autograd builds a computational graph. In this graph, each node represents an operation, and the edges show how data flows between them. Once you have your output tensor, you can call the backward method. This triggers Autograd to traverse the graph from the output back to the inputs. It applies the chain rule to compute gradients for all the tensors involved. These gradients are then stored in the grad attribute of each tensor. You can use these gradients with optimization algorithms to adjust the weights of your model. One of the standout features of Autograd is that it creates the computational graph dynamically at runtime. This means you can include control flow statements like loops and conditionals in your models. Even if these change with each iteration, Autograd will still compute gradients correctly. This flexibility sets PyTorch apart from static graph frameworks, making it a favorite among researchers and developers. In practical terms, Autograd powers the training of neural networks. It automates the gradient calculations needed for backpropagation. For instance, when training models like those behind ChatGPT or image generators such as DALL-E and Midjourney, Autograd manages the complex differentiation steps that allow these models to learn efficiently from data. Understanding Autograd also ties into the ethical considerations of artificial intelligence and machine learning. Its ability to facilitate rapid experimentation and model development means we must be mindful of how models behave, their biases, and the need for transparency. The ease of training complex models can lead to unintended consequences if not handled carefully. In essence, Autograd is a fundamental feature of PyTorch that automates gradient computation through dynamic computational graphs. This capability enables flexible and efficient training of machine learning models across a wide range of artificial intelligence applications.